Yeah,
You want it?
you can. It's a hard one.
Okay.
It's a hard
All right,
one.
guys, you ready?
Don't bring on the police.
So we have patient GG. This is the in-class practice problem one or something like that, I forget what it's called. Kinetics practice case number one, extra set for in-class practice. All right, so there's a bunch of information on here. It's pretty irrelevant
Why?
for the worksheet. This right here, this section in the middle is the important part because it has her weight, and we're going to be using her weight a little bit. All right. All right, so number one, calculate the zithromax volume of distribution for patient GG. What does this answer imply about the distribution characteristics of drugs? So you have to go to the equation sheet and we have to find out what we can do to solve for volume of distribution. So we're looking for volume of distribution. So the first equation here, we don't need to put anything for that. Just the 31. Oh, yeah. So we don't need the equation sheet. So above right here, it says zithromax has an average weighted volume distribution of 31 liters per kilogram. Right here. So we can set up 31 liters per kilogram times how much she weighs. So if we go back up here, it says that she weighs 64 kilogram. So times 64.
Is the thing recording?
That's going to equal 1,984 liters. So do you guys know what that means? Very good, yeah. So this means that zithromax is very well distributed within the body.
Do you guys have any questions on this one? Question number one.
What, like, so if it was like 104, that.
It's still pretty good. No, that's still pretty good. There's, I'm not sure if there's anything in the notes about what's considered like well distributed.
Yeah.
But that, I think it's more, he's asking more conceptually. So like the higher the volume distribution is, the more like penetration the drug has within the body.
If it's like 20 or 10, then it's bad. Basically.
There's a chart in one of the slides that has like different ranges of volume distribution that have like different categories to where they are. So there's like a certain ranges there in the central cavity and then the peripheral cavity. So just look over
It's
that.
in the notes.
It's just a chart in the notes.
Even I didn't know that.
It's like one of the earlier things, but I think for this one, he's just more asking, is this like good or not? But there might be a multiple choice on the exam that says, here's this, and then he gives you like the different cavities that it could be in. So I would just double check it. At most, it'd be one question that you'd ask.
All right, so question number two, it's asking for the elimination rate constant K for zithromax. So above it says that the elimination half-life is 35 hours. So the equation we're going to use is T half-life equals 0.693 over K. So we know what T half-life is, so that's going to be 35 hours equals 0.693 over K. Now we just have to rearrange to solve for K. So K equals 0.693 over 35. K will equal. You guys get anything yet?
I got 0.01.
Right, 0.018. Good. So for rate, we have to use 3 decimal places, right?
Yeah.
0.01.
Huh?
That's,
Yep.
that's correct.
Yeah, that's correct,
Yeah,
yeah.
0.02.
So it's gonna be 0.020.
Yeah.
Because we have to use 3 decimal places.
Okay.
So remember for K, we use 3 decimals. For concentrations, we use 2 decimals. And then everything else. We use 1 decimal. All right. All right. Question number 3. Calculate the clearance of Zithromax for patient GG.
That's them.
So I'll give you guys a minute to find clearance and then we can do it together. All right, so does anybody have an answer yet?
You guys know the equation to use? What's the equation? Someone?
What was it? Yeah, good. So in order to calculate clearance,
You guys have VD and K from last 2 questions.
right, you're gonna use VD times K. So what was the volume of distribution? Yep,
What was K?
perfect. All right, and what did you get for your final answer? What is it? 39.7? Perfect, yep.
So concentration is 2 decimal places, K is 3 decimal places, and everything else is 1 decimal place.
Or if you remember the acronym, so concentration will be K. It's 1, 2, 3.
All right, so if patient GG's weight is reduced to 132 pounds, calculate the new clearance for Zithromax.
So what do you guys think we should do in this one?
Yep. So do 132 divided by 2.2. What do you get for your answer? Huh? Yep.
Yes. What's the next step?
Yep. So we need to find V,
the one you're given.
right, so VD is gonna equal 31 times 60. 60.
What's the next step?
Nope, so that's just your volume distribution. It's asking for
We need,
clearance. Right,
yes.
so K stays constant regardless of those different factors, right?
Because it drug per drug basis.
Right, so clearance will equal,
Anyone have an answer?
37.
That's correct. I'm the assistant. I'm here for more support.
Moral support. Why'd you do that?
Max bid to the max.
We have to go to the line.
What is it?
37.2.
How did he keep that, Alex? Alex, you gotta fix it.
Fix it, bro, I'm not the one breaking it.
Let's go.
Put this thing over your shoulder now.
37.3.2 liters per hour.
All right.
Calculation questions, so they're gonna be all of them. So, okay. Because on the. Like on the Kodiak, there's like exam scrapbook one. So that's my guess, and then like the rest are like consumption or calculation we already have. So that's a problem, so if there's a minimum, it'd be like 5.
All right, so what dose of Zithromax should elicit a target plasma concentration of 250 micrograms per liter?
So what equation should we use from the equation sheet? Someone,
This is gonna be an intravenous bolus.
I'll give you a hint. They gave us dose and we have volume of distribution. We have to find the C initial basically.
We have CNS show, we're looking for dose.
Oh yeah, we have C initial and we have volume of distribution. We're looking for dose. So to find an equation that has like those two variables that are given to us.
How do you decide?
So it's just,
Because we're doing, it's a injection.
it probably said in an earlier like question. It's Zithromax.
Because it's just, this is just like a one-time dose. They're not saying that it's gonna be given over time, or it's not like a drip or anything, just a one-time push.
So what equation should we use? We have the initial concentration and we have the VD.
Those.
Exactly.
Yep. All right, so
What's the first step in this one? What's the first step? Someone? Someone? You guys need your coffee today.
It's so cool, I've never seen it.
Just chug it.
Just plug it in.
yeah, you can.
But there's one thing, read the question, read the, yes, exactly.
There you go, yeah, so you can change micrograms to milligrams.
Yeah, that's the first
Yeah,
step.
so
It doesn't have to be the first.
yeah, it doesn't have to be, you're just gonna get a really large number.
Yeah.
So
But
microgram.
yeah, usually when
Liter.
you'll know when if you just plug it in for micrograms, you'll see that'll come out to like a really huge number. And you'll probably, that would indicate that you have to convert it to milligrams to something to be like a normal like dose.
The initial BD, the one that's on the patient profile, or the patient. So
Yeah.
Yeah, that's 64 kg VD.
Yeah, there's a few instances of that where he's like, find that new patient weight, but then like completely disregard that because the rest of the information isn't around that.
All right,
But-
so now that we calculated the
Yeah.
initial concentration that we're looking at, we can use that equation that was it Ella that said the equation.
Yeah.
So you do 0.25, or I'll just write the equation.
Yeah, why would you not do that?
So C0 equals dose over VD. .25 equals dose, and then what was the volume and distribution that we calculated?
1860.
The first one,
9.4.
what was it?
9 is 84.
94.
Oh, that's what I did too, but it says.
Anyone have the answer?
496.
Yeah.
Milligrams
Meeting
per
tomorrow,
Good.
Jake.
Yep.
For April, we're meeting tomorrow.
496 milligrams, yep, which makes sense because Zithromax when you're dosing, your first dose is 2 tablets, which is equal to 500 milligrams to get you to that initial concentration.
Yo, next question. Do you use this way to get the fraction?
We can do both.
Start with the one in the,
So that's where you're gonna look for the fraction. Fraction.
yeah, so figure out n first, and then go be there.
I just-
Sure, both ways.
All right. All right, number 6, Zithromax. Assuming that Zithromax is 100% bioavailable upon oral administration, what percentage of the drug remains in the body 70 hours after administration of initial dosage? What percentage will be eliminated? Okay, so
Nope, first that's gonna take.
So if it says 100% bioavailable, what do you think the initial concentration will be for this? Yeah, basically 500.
Yeah.
So they're taking 500 mg.
so C.
Five. That's what I'm saying.
Okay, good. All right, so for a fraction remaining. Do you guys know what the formula is for fraction remaining? What is it?
What, 0.5?
Yep, 0.5 to the n. And then what does n equal?
T over T half.
Yep, so n equals time over half-life. So how much time has passed? 70, and then what's the half-life of the drug? What's the half-life of the drug? 35, yep. So n is going to equal 2. So now for our fraction remaining. 0.5 to the second power. So the fraction remaining equals 0.25, which equals 25%.
So the question is asking for what percentage is eliminated. So what do you think, if we have the remaining at 25%, so how much is eliminated?
What's that prices?
75, yep.
Also, guys, could we use negative e, no, e to the negative k times at a time?
Yeah.
Could we do this?
Yeah, sure. You have to do that one out.
Oh, no, but like, I'm wondering if we have to, round it to a whole number, cause I got 24.6.
Yeah, so you just round it to
Okay.
a whole number, but either way, it's gonna be correct.
I think it
Okay.
might be multiple choice.
Yeah. For percent stuff, you'll take 1 decimal as well, so you have 24.6, whatever other number it was, so.
Yeah.
Good enough.
Like if it's 24.6 and multiple choices, 25%.
Yeah,
Okay.
I think his
probably-
open answers, you can get like 20% like difference or whatever. So like if you had like rounding issues, if you're within 20% error on your final answer, I think he still gives it to you.
Okay,
I think that's what he's talking about in class, where if you rounded or put a different number of like decimal points for like K value, but you did all your calculations with that. If you're like within 20%, I think you're still good. So don't like freak out too much if you do it like a slightly different method, but just like look at that and be like, oh, does that make sense? And then you can do it both ways to see like if your answers were close.
okay.
But obviously they'll take a lot of time, so just weigh up your options when you're taking your exam. It's another calculation or it could potentially have answered another question.
All right, so for fraction eliminated. It's easy, since we know that 25% remains, we can just do 100 minus 25, so fraction eliminated would equal 75%. Any questions on 6? No? All right. Question number 7, how long will it take for a dose of Zithromax to be clinically eliminated from the body? So how many half-lives does it take for that to happen? 4 half-lives, good. So what's the half-life of Zithromax? 35 hours, right? So 35 times 4. What's that equal? That's gonna equal 140 hours.
Does this make sense?
Does that make sense? Yeah. Good.
Yeah. I was about to-
All right, so still the same patient. Patient GG was given an IV administration of Zithromax. Calculate the area under the curve of plasma concentration versus time. If you know that the administered dose is 500 milligrams and the elimination half-life is 35 hours. So I'll give you guys a couple minutes to work on that and then we can go through it together.
Also, don't forget, Dr. Cohen's gonna also have his own review on Zoom today as well. I forget what time he said though. Is it like at
6
4,
6 p.m.
6 p.m. or something? So it's later tonight. It might be recorded, but it might take several hours
Said he was gonna post it.
and stuff. But yeah, try and join it live. If you want immediate help at the task last question. Because I know last semester he would do the same, but what ended up happening is it'd take like a day for something to the recording to get like uploaded. So I wouldn't like bank on that as like your sure way to like review. I would highly recommend attending for that if you can.
We already.
Yeah.
They probably go for like exam procedures. So I know on Kodiak, there is like exam 1 scrap work stuff and exam 2 scrap work 3 and 4. My guess is that'll be distributed. And you'll like write on it as to show your work for open answer questions that are online.
So you know how in classes, like I have 30 questions and then I'm gonna pick a choice and then the other 20 are like open-ended.
Yeah, so that's probably what the paper's for, is those open-ended questions to get partial credit back. So there'll be like a text box, or whatever, on the exam, and then that paper. You're also submitting that paper is what I'm guessing. Don't quote me on that, he's probably gonna be talking about that later. Yeah, basically it'd be 20,
Is it gonna be just like this?
probably. It's gonna be like the ones we did on Friday as well. The reviews we did for that, I highly recommend going over that. He
You guys good with number 8?
seemed like it
Anyone
was
have
gonna
an
be
answer?
exactly the same questions, just different numbers. So I'd look over those as well.
So it's probably gonna be like,
Is it not gonna be
K
times
times
or
hours,
hours?
that's
Yeah,
right,
it's gonna
so
be
you get like
times
one
hours.
wrong, like the others, I feel like that's gonna do wrong.
You get per liter.
Yeah, if you get the, like, say you wrote like a wrong K value, he's probably not gonna like punish you for the rest of it. I think he's gonna be like, oh, you did all your setup and stuff, but you get like. You might get the first one wrong.
All right, so for
Anyone?
number 8, who got an answer?
I have an answer and then she's right. I want someone else to get it. Before we disclose it.
We're asking for promotion on Monday morning.
Gotta be ready, dude.
Yeah. Could be second.
Wednesday morning, he's gonna be asking too much too.
So look on the worksheet.
Yeah,
Not-
yeah, that's what
Yeah.
we have those.
Yeah, so we have, I think we calculated clearance above, right?
Yeah.
Yeah, So the equation we're gonna use is AUC equals dose over clearance. But if we didn't have clearance before, it would just be AUC equals dose over VD times K. So AUC, so the dose is gonna be 500. Then what do we calculate for the clearance above? 39.7. And what'd you guys get for an answer?
That's correct.
Equals what? 12.6. And then the units are milligrams over liters times hour.
4 milligrams per hour over liters. It's just written out different way. But same sort of answer. Because if you remember, your units for K is 1 over hour. So it's like volume distributions. Liter. So when you divide it by the flip around, so.
Fourth at 9 AM. Yeah. A class at 9.
That's what I'm doing. Why is this so?
Yeah, we have until this room until 12.
All right, question number 9, predict the plasma concentration of Zithromax 12 hours after the first dose was administered. So do you guys know which?
Equation to use? Anyone know what equation to use?
We're not, for this question, we're not thinking that it's 100% bioavailable. So before you do anything, you have to solve for the initial concentration.
If you use the equation, we already used that equation today, so. That's your hint, use that equation to find initial concentration.
Yeah, look at your chart, figure out which one says initial concentration equals something.
Or using the dose of 500.
Yeah.
Hey guys, is this helping or something? Okay. Yeah, I'll take money. I'll take cash.
Abdullah, you
I
don't
have
get paid by the school.
We paid Cardi.
Huh?
We paid Cardi.
In what?
Hurry.
Hurry?
That's great.
You know, it's recording, that's the, I can report it, I can report you, like report you to HR. For this recording, I hope you know that,
HR.
I hope you know that.
HR is crazy. It's not HR. it
HR
would
is
be-
Cam,
Oh, yeah, Cam's HR.
yeah. Of this
No,
class,
that would be what, the secretary?
human resource,
Well, yeah, but Cam's not human resources.
I'm
It's the
kidding, of
president.
course I'm kidding.
Where is?
Anyone have initial concentration for this question? That's correct.
Yep.
And then what equation do we use? So we have initial concentration, we have time. Exactly. So let me know what you get for the answer.
I got a small number.
What do you get?
9.4.
0.2 is the answer.
Okay.
0.2.
0.196 is 0.2. Yeah.
I'm gonna ask my calculator.
That's not initial concentration.
So another helpful tip for like looking at this, so say, yeah, you got a small number, right? But you're like, oh. Is this right? Like, maybe you don't wanna like necessarily run through the entire problem again. So a good way to like check to see if you're potentially immediately wrong is to look at what so it says when it was first administered, so we know its concentration at. Oh, wait, no, we know its initial and we're looking for its concentration at another time. So if you calculated a number that was bigger than what your initial concentration was, then you know you've messed up somewhere, maybe misdone in your calculator
Do you guys get a final
or
concentration
something.
after 12 hours?
Oh, yeah, does that make sense?
Yeah, that makes sense.
Yeah, because it's the
You
same,
guys,
you got
0.5.
1,000 or something, you know you're wrong. Because
That's
there's
muy
no way
perfecto.
it's going to be
Zero.
bigger than
Zero point
what you
zero-
started.
0.20.
Just
Yeah.
can't happen.
Okay.
Since it's
So that's
concentration
just a
into
good
the
like little tip to see where, like, maybe just inputting your calculator wrong, so I would just double check that before having to like rearrange your entire like equation, and that's gonna like eat up some time too.
Sure. Yeah, I keep my math to make that clear.
Question 10 is exactly like question 4, so you guys figure it out.
Jacob, are you on your phone in class?
I have the class.
While teaching the class, that's irresponsible.
Did you mean to write 0.25 instead of 5.2?
Sorry,
What? Where?
What says C equals 500 times?
Oh, yeah.
that should be E, not C, that's what you're saying.
What?
Yeah, it's not 500, it's 0.25.
No,
Oh, sorry, yeah,
Yeah.
you're right, yeah, sorry. Thank you.
I think she's saying that should look at an E.
Make it more E-like.
Is that E enough for you?
No, some of them don't make 0.25,
Yeah.
but it is.
Yeah, because concentration is mass divided by volume, so your dose isn't necessarily
Anyone have an answer?
always
Discard it
going to
already.
be the same number. In fact, it never is. Unless you're talking about amount, then amount is always like grams of or milligrams of something. Which will be
They said someone-
helpful in a later question when it is asking you for amount, then it's looking for grams or milligrams.
All right, do you have an answer for 10?
I have the answer is correct, I want someone else to figure it out.
Yep, 7.5.
Yeah.
All right, so first thing you gotta do is change it to kilos. Divided by 2.2, which equals 31.25.
Yeah.
Which equals 125 kilograms. Then you have to divide, multiply by that constant, which is 31, liters per kilogram. Then your new one is going to be 77.5 liters.
Nowadays, noise clearance, so it's milligram liters per hour. Liters per hour.
And don't forget about your units, because in the exam, it might be open answer like blank, and then he might ask you for, okay, what are the units? But also read the question, because he also could say he doesn't care about units, but yeah. That's just a possibility, so don't always just disregard the units sometimes. Because that could be what he's asking, or like he said in some multiple choice answers, he likes to change the units on each, so.
So number 11
Double check those.
is basically what we did before too. So you guys can figure out that one too. If we taught it well.
Pay attention to the units. You can solve it either way.
It's chemical.
No,
Wait,
see, there's
Yeah,
no lines.
the weight.
I mean, I can flip it and it'll be on.
I think it's 64 kilograms. It is. I'm gonna tell you. I think it's what?
What's your
We didn't
question?
specify, you know. I
Like
think it's
what,
covered.
which way do we have?
64. The actual patient's weight.
Yeah,
Yeah, just go by actual patient.
Yeah,
When he asks for new weight, then use a new weight, but if he's like asking a question in general, then use the actual weight in the case.
Yeah. Yeah, unless it says using new patient weight or using the information in question, whatever. But assume it's original patient weight. Alright, I'm gonna go to Dr. Balzani's now, see if she's here or not. I'll be back.
And it's a new drug, so we have to find new K. We can't use the same K as the Thromax. This is a new drug. Where did the put that? You have an answer?
23.
What do you get?
Per hour.
23.
That's 21.97.
That's what I got.
21.97, which is really just like. Maybe by 20.
I got 21.8, but maybe it's like around something.
It could be from the K too.
Yeah.
Yeah, that's basically what I know.
Anyone else have an answer?
Still working? Still working?
Still working?
They're gonna ask you one more time.
They're gonna throw that coffee mug at us, bro.
What has to learn to say this? Three. What? Three. There's no one decimal place for. Updated everybody. Because you forgot to put a. Credit for the chief of the company question.
Still working?
Say 20 minutes.
Yeah.
That.
So, Dr. Kohan, he also posted an answer key to this. And he did in the minutes, he didn't change it to hours. So we can do it in the minutes too, basically, like liters per minute.
We change it. I mean,
No,
last-
he did it in minutes, but we can do either,
Yeah,
depends on,
both answers are correct.
both answers correct.
It doesn't matter. So,
Did he still get one?
No, but in minutes it will be different numbers.
yeah, I think for minutes, you got like 0.4
Yeah.
after rounding.
Yeah.
I think it was like 0.3.
Yeah.
Yeah,
The unit's gonna be
without
liters per-
rounding,
It's a liters per hour.
Yeah. All right, so let's
He
solve.
did in minutes, Dr. Kohan's answer key, he posted an answer key too.
They'll probably ask you.
Yeah,
and
the example
he'll
is here.
specify.
Yeah.
Yeah.
So let's just do it for minutes, and then we can just change it to hours afterwards, so. So T half-life is 260 minutes. Equals 0.693 over K. So K will equal. Zero, zero, zero. 7. Per minute,
Yeah, but this is per minute, you guys are per hour,
Right.
so that's why K would look different.
so then K, if it was per hour, you have to just divide it by 60. So if we change this to,
4.33.
2 per hour, you just do 260 minutes. Times 1 hour over 60 minutes. What would three hours. 0.693 over K. K equal 0.160 hour. Is that what you guys got for the hour, K?
Yeah.
0.160. Okay, so now to calculate for clearance. Okay. All right, so then we gotta solve for volume and distribution of the patient. Which equals 2.13 times 64. Which equals 136.32.
Did everyone get this? Volume over distribution.
Then clearance equals volume and distribution times K. So for minutes, clearance equals 136.32 times 0.0027. And then for hours, clearance equals 136.32 times 0.160. What'd you get for the hours?
No, 21 point, what was your answer for the
Oh.
clearance?
They were asking of the hours.
Yeah, because we're doing both minutes and per hour, yeah. 21.8 is good. And for minutes is. Let's do it out.
Wait. 36 milligrams.
Liters per. I mean, I don't know. No, that's not it. Let's see, you see. It's liters per hour. Liters per minute, liters per hour.
Right, any questions on 11?
If he gives you minutes, if he gives you minutes and you have to solve for hours, we can always find this too, and then convert this into hours.
Yep.
We're using the what dimension analysis?
Dimensional analysis.
Yeah, from calculations class, semester 1.
You're telling me we have to use calculations for the rest of our lives?
Yeah.
All right, 2 more. I talked to the pharmacist that I was working with yesterday. He's like, yeah, I don't remember any of that stuff.
Yikes.
All right, number 12, patient GG was administered an IV dose of 500 milligrams of an ampicillin for the treatment of an infection. If the amount of ampicillin remaining in the body 6 hours after the administration was 20.8 milligrams, calculate the half-life of ampicillin.
So what equation would you guys use for this one?
Is it the LM,
Which one?
the LM?
No, not that one. Read the question. They gave us the initial dose. They gave us the final one, and they gave us the time.
And we're assuming that since it's an IV dose, it's gonna be 100% available.
Yeah, we don't have K, we have to look for K. And with K, we can look for half-life, we can search, we can find out half-life. So what equation? We have final concentration, we have initial dose, we have E, we have T.
Nope.
So this is the C, C0.
Yep.
Over the other sheet. Overnight classes. Yeah. Anyone have an answer? So we have to solve K first, and with K we can find the half-life. You have a question? Yes.
Yeah, for the negative K to find it, since we have fraction remaining and time, could we use the E to the negative K times T equation? I tried, but didn't got it right there.
You don't know. You don't know what the half-life is, so you can't use that, because you have to use, or the e to the negative kt, you're asking?
Yeah, cause I found N and then.
How did you find n? Because it doesn't give you what the half-life is.
It can't. Yeah, N and then you use N equals T over T half-life.
Right, but you're solving for t half-life.
Yeah, and then the time would be 6 hours. I found it. Yeah, and it was like 2.5.
So how did you find the fraction remaining?
Okay, do your way and tell us the answer.
I erased it.
Oh,
I did it already, but you guys are doing a different something. I think, I got. I don't know what she's doing. I was like, wow.
give an answer.
Yeah, I don't know if it's right.
You can say.
1.3.
Yeah, that's what I got.
1.3. So
That's correct.
the answer is yes.
Yeah.
That's what I got.
No, but yeah, your way works too.
Yeah, so it works.
Since it's math, you can use different equations to figure.
Okay, well, they didn't say it was right, like, you can only go this way, you can go backwards, but then like, we do it for K and T half-life, back and forth all the time, so what the fuck is the difference?
Jacob,
And we always
if
get
you
different
use the fraction remaining,
That's right.
what you would
Like,
just do,
wait,
it's exactly fine.
20.8 over, yeah, it's rearranged.
Yeah,
Right.
It's
I think
like
it's because I.
E-
Right, yeah.
When you do natural
Yeah,
log,
yeah.
it's exactly.
It's
the
exactly
same.
the same.
Okay.
The fraction, it's exactly the same if you were to give the setup for the concentration equals initial
Yeah,
concentration.
you're right.
It's exactly the same because.
You can do it that way.
So you can do that a lot.
Right, yeah.
Yeah,
Because when you use this equation. When you rearrange it, you're gonna get C over C0 equals E negative KT, which is the same as finding fraction. This is fraction remaining right here. This fraction remaining.
It's the same thing basically.
Yeah,
yeah.
so it doesn't really matter which way you do it. Because you're gonna end up doing it anyway. So it's gonna be 20.8 over 500 equals E negative K times 6.
I mean, conceptually, technically.
And then you
that would
just
be
take the
right.
natural log of both sides. And then you get negative 3.17 equals negative.
So if it's 100 variability, do we assume that the C0 is equal to the
to those, correct, yep. Negative 6.
Technically, no.
If
No,
it's
it's 100% bioavailable.
Yeah, but your concentration is technically going to be different because concentration is grams per liter. And you're only given grams. So, I mean, if you knew
But-
BD, It's just more
It works.
complicated, but if it
If it
works.
says 100% bioavailable, the question is just C zero is the dose.
Just assume
Technically, it
that.
does, according to
Yeah,
technically it's
technically.
not, but in our math it works.
Yeah, it just conceptually understand that all of your amount that you're giving to the patient
Alicia,
is
you were,
going to be at the
you
very
were on
peak,
Zoom,
at the
how's
very
Is
start.
it working good?
Yeah.
Okay.
So technically with the fraction remaining equation, technically that would be the most conceptually right, because the remaining doesn't necessarily have to be a concentration, it could be an amount. And this one doesn't, but with their setup, they're using concentration, but as we saw before, they get to the same spot. It doesn't matter with the math, but don't confuse yourself. I'm not trying to, but you know.
What are you saying?
2.8 over 500, what does it say after that?
Huh? I'm
So I
sorry,
was saying after 20.8 over 500.
What does it say after that?
That's natural log,
equals, ln,
natural log.
yeah, cause we took the ln on both sides.
Okay.
To get rid of the e.
I call it national log, not natural log.
National law.
Natural log. Yeah.
It's crazy if you know.
We are on last question, but last question is like we have to find four
Yeah.
times the last question.
Dr. Gonzani was there, but she's talking with another professor. It's like, I'm not gonna interrupt them. That's why. Since you have to turn it on, stupid.
Hey. Don't come stupid.
Yeah, hit their eyes so that they can like get a doctor's note because they're blinded and they can take the exam on a different. Brilliant idea, Jacob. She's trying to do this eye so he gets $3,000 of LASIK surgery.
Yeah, I put it in my eye, you owe me 3,000.
Alright, so for 13, let's use which points did we use?
We use 1 and 3.
Alright, let's use, so he's gonna tell us which points to use.
On the exam, he's
On the
gonna tell us
exam.
what points.
Yeah,
Are we
so
using?
use these 2 points for question number 13.
Yeah, and this he did, but in the answer key he uses 1 and 3. So we're just doing it the same.
On exam, he's gonna tell us what points to use.
Yeah, one and.
1 and 3
his
we are
question
using right
didn't
now. Cause
Specify,
on answer key, he's used 1 and 3 as well.
yeah. So just use 1 and 3, but typically you probably want to use a later data point. I don't know why he didn't do that here, but. Yeah, the answer key uses.
Later point and it tells us.
Yeah. Then he also rounds all of his K values totally wrong. I don't get it. Probably find K first.
Those over say that we saw. Does anyone know how to do VD on this one? What equation to use?
No.
Yep.
Yes. So what is CO in this question?
Yeah.
Perfect. And we have the dose. Shout out the answer if someone gets it. For VD.
Here's where I was talking about where technically your dose isn't always gonna be the same as your concentration, because IV bolus is 100% bioavailable. And we're giving them 1,000 mg, but their initial plasma concentration is not 1,000. So that's what I'm saying, it's.
Anyone have
understanding
VD?
Conceptually, it's like, yeah, it makes sense, it should be your very earliest moment, but. You know,
Anyone have VD?
if you're talking about amount and the question's asking for amount, then you're fine. But if, you know, like there was a question earlier where we didn't know our initial, but we knew the dose and VD, where you then had to calculate your initial.
So before finding the clearance and AUC, we need to find K first, because we're gonna use K to find the other two things. So next step is finding K.
Do you guys remember what the formula is to find K off a graph? What is it?
ln C1 by C2 over G.
Perfect.
You should.
So shout out the answer when you get the K.
Yeah, or 5.
It should be 3 decimal places, so. K is always 3 decimal places.
Yeah, that might be a spot where he might take up credit on a open answer.
K is three
According to-
decimal places, concentration is two decimal places, and anything else is one decimal place.
So if you remember 1, 2, 3, so I remember everything is 1, concentration is 2, and K is 3. So just the helpful way that I remember it. This, 1, 2, 3. Heck, 1, 2, 3. That's everything, 1, concentration 2,
Any
K is 3.
Okay, that's all.
Just Sophia, did you guys find K? What? Perfect. Now we can calculate the clearance. Open profile. Using the equation. Did you guys find the clearance? What is it? B times K.
6.4.
6.4, 6.5 is correct, yes. And there's an AUC equation too. It's there's a gradient of AUC on the sheet.
Yeah, use that one. In the
Yeah.
answer key, he uses the
Trapezoidal method, but he said trapezoidal is not gonna be on
Yeah,
the exam.
trapezoidal's not going to be on the exam. But if he asks you, like conceptually why in theory you would use it, it's just because it's like more
Well,
accurate. But
There's simple AUC gradient on a gradient sheet.
Yeah, but
Use
if he's
that to
asking-
find the AUC.
for AUC, just use the one in the
Yeah,
equation.
you have dose, you have clearance.
Yeah, or dose over VD times K. But yeah, it'd be dose over coefficients. Yeah, use that one in the equation sheet if he's asking for AUC.
And shout out the answer if someone gets it. For AUC.
That one was 6.3.
Did you guys get this answer? Okay, perfect.
From milligrams per liter times hour. Yeah. Or you could do make time over. Which is how I write it. I didn't know. I didn't either. I just wanted to flex, because mine is written more.
So we're done with this sheet. Anyone have any questions on this sheet? This practice set?
Did anyone watch Dr. Kohan's Friday lecture video from last week that he posted on Wednesday? So he does, the entire thing is about practice problems.
Yeah,
I recommend if you're still like Friday's last Friday, last time we had class, all we did was practice problems, correct? Right? So those ones I would look over to like double check, but I would also look over 2 weeks ago's video that he posted on Wednesday, because he's just going through practice problems there. It's the entire thing is just practice problems. If I think they're unique. I couldn't find them anywhere in lecture or anything. So I would look over those if you're still struggling with like practice. He does some.
You guys want to do the one that we did in class quickly? Like the one that we did at the end of last class that he took like 2 minutes on? Yeah. Just gonna add it. Just give me 1 second, I gotta add it to my one now.
SMH, you don't already have it prepared. I think they're in the lecture stuff.
no, that's not the answer.
Yeah, it's not about it.
Question eight. Is that what Okay, well, what if that- Yeah, one of them.
You guys understood though that worksheet, right?
Yeah.
Okay, yeah, that was too bad.
It wasn't bad, right?
I think I need to study the conception.
Yeah.
Yeah, don't
Start asking
sleep on.
questions and I'm gonna be confused.
Yeah, those multiple choice, don't sleep on the conceptual questions, because he could ask you pretty much anything conceptually, in addition to like quick calculations.
I always get the math right, it's like, as long as my calculator works, I can.
It was 0.21.
But then it's like the conceptual things, if it's like, say, or like two answers, sound like they could be right.
Yeah,
Alright,
Yes.
so these are the questions that we did at the end of last class.
were these the ones
Yeah.
that's like,
So this one, these, if you're gonna do anything like study hard, look at these, cause he said that these are very, he's like wink, wink, nudge, nudge.
Yeah.
These are
Yeah.
gonna probably similar to what you're gonna see in the exam.
yeah, probably different numbers.
So,
Maybe the same numbers.
Maybe the
no, we
same.
can't.
No.
you never know.
Then you're gonna get the answer and you're gonna be like, oh my god, I got this answer.
Yeah.
You must be right.
alright, so use points 2 and 4. It's asking for the elimination rate constant, which is just the K. So that's the same equation that we just used before. Yeah, so that's gonna be L.
So
Salad, really,
black one.
$50. 200, they computed them working by for $100.
So what did you guys get for question A?
Question one.
Yeah, 1A. What'd you get for 1A?
Oh, it's for K, right?
Yeah,
Yeah,
for K, yeah.
Zero, zero.
Yeah.
Yep,
0.00.
Yeah, don't forget
Yep.
that is 3. Like,
Just
don't,
add 0 at the end.
yeah, don't drop off at 0, still, he's still gonna wanna report it in 3, so. When you're calculating, you.
alright, and then
forget
what
about it,
fraction of the
final
dose
answer.
in the body
That makes
remains
it sorry.
after 7 hours after
Units, don't
administration?
forget your units.
Alright, so fraction,
Your hours are capital H, that really bothers me.
huh? What, you don't like the capital H on the
Your hours is like capital H.
Yeah, you don't like it?
No,
Oh.
it's ugly.
Oh, shit.
What?
That's why we're fine.
You wouldn't say that.
That's not
to-
They gave you a half one.
I don't think you're allowed to.
Yeah, it's probably illegal in some countries.
Yeah, it's illegal.
What?
I'm gonna get arrested
What?
for your
The
capital.
capital wage.
Good, if I get arrested, then I wouldn't be in toxic school,
We're
allegedly.
allegedly. You can be a street pharmacist.
Once the front gates go down, the back gates go up.
Oh, what type of gates?
Okay, so for this one, it'd be easier if we find what the actual half-life is. So we can do T half-life. It's not English.
Bro, it's not even the numbers.
T half-life equals 0.693 over 0.08. So the T half-life,
Anyone have half-life?
8.6.
Yes. 8.7.
8.7, yep.
The north, North.
Alright, so 7 hours have elapsed, so your N is going to equal 7 divided by 8.7.
James and. You can follow my. No, thank you.
That's gonna be equal to 0.8. So your fraction remaining is going to be 0.5 to the power of 0.8. Fraction remaining equals
It went by 7 over 57%.
No, I was like, that's not.
0.57,
What you get at, is that what?
which is equivalent to 57%.
Everyone got that?
Are we comfortable with getting there? It was like the same on the previous worksheet.
Everyone good with that? Any questions?
Any answers?
Yeah, any
Do this
different
again next
answers?
Monday for medicinal. We do this again next Monday for medicinal.
But we don't have calculations from medicinal or
Yeah, but we can do a review on Monday.
med chem. It's all
That's
Just conceptual.
common sense.
common sense, and your functional groups, don't forget about those, just keep.
Yeah, no, that's.
Yeah, I can do
Are
it.
we good to move on?
I can have with the, I can.
Alright, Alex is a 55-year-old male patient weighing 75 kilograms, who has been given an IV bolus of 100 milligrams of gentamicin for an infection 1 hour ago. The VD is 0.30 liters per kilogram. Estimate the gentamicin peak serum concentration. Alright, so which Which equation are we gonna have to use? So what are we looking for?
We're looking for C max, not C zero, it says peak.
Yeah.
Equation is same, but like the wording, I don't
Yeah.
want you to get confused later.
Yeah.
So it says peak plasma concentration. Peak is max.
Since it's IV, since it's an IV, doesn't it like peak, since it starts like from the top and it starts declining over time. That's why it's saying like initial, because
Right, because you're gonna
Zero.
go to the peak and trough. So like when you administer something,
Yeah.
you don't just like start here. Like, cause remember, you don't have anything in your system. So you're gonna slowly build up that concentration over time. And then you're gonna go like this, and then you give another dose, you're gonna go like this. So it's not like you're at zero and then you automatically go to the top.
Okay.
You slowly increase over time.
Got it.
Okay,
Yeah, thanks.
alright, so Cmax is gonna be dose.
Yes, Ella, technically it's the same equation,
Yeah,
but like the wording is C max. I don't want you guys to get confused.
yeah.
Yeah.
And so you're still looking for the same thing.
It's, there's a, on
I
your
would say
equation
peak,
sheet.
peak
that-
is max.
Yeah.
Yeah, your equation sheet will have C max equals, and then this, exactly,
Initial.
yeah.
Yeah, it's, yeah,
In this situation, it might be different, but in this situation, this question is the same basically.
Yeah,
Yes,
yeah, 75.
it's what dose divided by VD.
what would you get for the BD? Dose equals 400. Yes. What'd you guys get for the answer? Yep,
Yes.
and remember, this is a concentration, so we need
That's,
2 decimals.
everyone got that?
Good to move on, question 3. All right, the plasma concentration just after an IV bolus of amikacin dose is 45 milligrams per liter. And the patient's elimination rate is 0.08 over hour. Predict the plasma concentration after 12 hours. So what are we solving for? Yeah, we're solving for C, or for C, and then what do we know? Yep, so we know C 0.
What else do we know?
Okay.
Yep, and we also know K, very good. So which equation are we gonna use?
Yes.
Yep, very good. All right, so we're gonna be solving for C. The initial concentration is 45 times e to the negative 0.08 times 12. Let me know what you guys get.
Anyone have an answer? Yes, 17.23 is correct.
Good stuff, guys. Good stuff. Good stuff. Any questions on number 3? No questions? How we got there? Very good.
Yeah, pay attention on these ones, like you said, it might be on exams, because you
Yeah.
said wait, nudge, nudge.
Yeah, he's like, probably definitely see them, maybe different numbers.
Yep.
But conceptually, these will be asking for the same way, and you'll basically do it the same way as well.
All right, a drug with VD of 0.8 liters per kilogram was administered to a 12 kilogram patient by IV bolus injection in a dose of 3 milligrams per kilogram, which resulted in a concentration of 2.5 milligrams per liter 3 hours later. How much is the elimination half-life of this patient?
What is the dose?
Doing a lot of work.
So we have a lot of parts here, a lot of components, and we gotta solve for like the big parts for the equation.
What do we need to find first?
I'll probably just give up.
Check the video.
BD equals 0.8 times 12.
This patient is Alex, by the way.
Yeah.
Or KG patient.
What?
That's Alex.
Yeah, oh, yeah.
Yes, we asked Dr. Gohan, this patient was modeled after Alex.
He
Yeah.
said yes.
Yeah, 24 pounds,
All right, and then what's the next thing that we should solve for?
26, whatever it is.
Oh, it's very good. Three times 12. And what do we get? 36 milligrams, very good. All right, so now we can, so what do we have to solve in order to be able to find half-life? What do you have to find?
Okay, yes.
K?
Yeah.
Yep. So which equation are we gonna use to solve for K?
Yeah.
To get over whatever you see.
Yeah, we got it.
Oh, we can.
We can put that together. It's a bit different.
Solve for usually.
Yeah, we have to find K.
Right, we have to find for K. So we have dose and we have VD, right? So what does that mean that we can solve for?
Yeah.
Very good, yep. So C0 is going to equal dose, which is 36, over VD, which is 9.6. So C0 is going to equal 3.75. So now we have initial concentration, we have the concentration after 3 hours,
We have 3 hours as T, so
right?
what equation will we use?
So change of Y over change of
You can use.
Yeah, you can use either way.
Yeah.
How else would you?
So the way that we did it initially was we used the
C equals C0,
C equals
Yeah.
C0 times E.
because we have everything now, except
Negative
K in
KT.
that equation.
Yeah, so C equals 2.5.
Personally, I like that better than using natural log one.
Yeah,
That's just
The
me.
natural log.
Basically, this technically
Makes
becomes a that
It's
equation too.
exactly the same
Right.
calculation. You're just gonna, instead of having to write all that out, you just put. You just use that equation.
Or-
It's just a faster.
And then
way to do it.
another advantage of using the ln equation is that you don't have to find C initial.
There you go. No, you're C9, so this. Yeah, it's concentration 1 over concentration 2. You only have one concentration, you still need to find for another concentration. It's exactly, you're just skipping a step, instead of having to write it all.
Okay, got it, bro.
Just do whichever way is more comfortable for you guys.
Anyone
If-
have K
If you
yet?
do it out this way, you're showing the professor that.
Or
this
Jacob has the
what
K?
equation or what concept you're using. So just be careful when using shortcuts. It's like, it might save
How do I
like a
turn
few
it?
seconds or 30 seconds, but. You know, if you get it wrong. Yeah, he might give it to you, but there's a chance he might not.
I turned you off.
Thank you for muting.
that's what you guys got for K?
Yeah, it should be 3 decimal places.
Yeah.
K is always 3 decimal places.
All right, and then T half-life. What'd you guys get for T half-life?
5.1 is correct.
Good, any questions on 4?
So one doesn't feel which is.
Yeah, it could be 1 decimal.
That's just one, that's this hour.
It's
Yeah.
everything else.
Yeah, it's not a rate.
Concentration, okay.
Yeah, it's not concentration and it's not the K value. So. What? Or you can remember X.
I just got it, even though I didn't hear it, but I got it, wait.
Okay, question number 5.
So stupid.
A 60-kilogram patient is given an IV bolus dose of an antibiotic and a serum concentration were determined at 1 hour and 4 hours after administration. Right, so now we have 2 different time points.
Yeah,
The concentrations were 2 micrograms and 0.5 micrograms respectively. What is the elimination half-life of our for this drug? Assume 1 compartment model with first order elimination kinetics.
so basically this is the table, you know the table he gives us?
Yeah.
This is a written out table, basically.
Yeah, instead of
Yeah,
so
wrote it out.
So which equation are we gonna use? Right, the slope of the line, very good, yeah, so it's gonna be ln,
What would be our C1?
Yep.
And what is the difference in time?
6 hours.
Yes,
good, yep.
solve it out, the K would be, anyone got K? What would I be?
I was confused.
Anyone have K? No?
Shift J, come on.
We did it in class.
You only have, and how long is the exam?
0.46
An hour?
is correct. 460, 0.46.
How long is the exam do we have it for? Is it an hour?
It's about for a period.
Oh, 2 hours.
Full hour, 40 minutes, an hour.
0.46.
Yeah, so you have an hour and
0.46.
40 basically for the exam, so don't like. Lose your mind on needing to do the equation.
It's a long exam. It's an hour 40 exam, so.
Now 40, but a lot of your time's gonna be eaten up with this calculation, so maybe start with a multiple choice first. Is test taking skill, so.
Bro, they don't need test
I got
taking skills, bro. They're in pharmacy school, bro. They're taking many tests, I'm pretty sure, bro.
Yeah.
They don't need test taking skills, bro.
They're not.
But you know how many idiots come to my tutoring session, though, they don't know those basic
Bro, they're in
skills?
pharmacy school. There's no pharmacy school kids in here.
Okay, so we got the K, now we have to solve for half-life. So T half-life equals 0.693 over 0.462.
I was teaching test taking skills. That was so funny.
What'd you guys get for
I'd
T
say
half-life?
organic people, organic chemistry people, just second year.
Yeah, that's
Yep.
right.
I'd say organic chemistry, second year students come in and they're like, oh, I didn't know I could do these zero questions.
I'll meet with Baker. Thank you, guys.
You can leave.
I have a meeting with Baker.
Have fun.
Oh, why do you have?
Oh,
to be
Baker.
You have to see his beautiful face.
Thank you for the review.
Probably. Yeah, I'll take check.
Yeah, he-
I take cash card, then no, cash app sell.
I have a credit card, my change, you can swipe it.
You have a personal ATM carried in your backpack, that's why it's so heavy.
Exactly that.
Okay, so. A new drug was administered as a single IV bolus dose of 5 milligrams per kilogram to a healthy volunteer. The pharmacokinetics of the plasma drug concentration time curve fit 1 compartment model. The equation is given right here. So here they give us, just you have to break this down. So they say CP equals 90 E negative 0.4. So
So based on this, what do you think the K is?
good, yeah. So this is basically just this equation. So C equals C0 E
And what is C0?
negative K times. Very good. So we know that C0 equals 90. We know
Yep.
that K equals 0.4.
We might go to Shaw's yet. So we can go there too if you want. Okay, we can, yeah, we'll be done in like 15 minutes.
Alright, so PP,
About 10-ish. Yeah, we might not have time. How about you meet us there? Yeah, let's meet. In Shaw, at Shaw's. Or you wanna go to Chick-fil-A, we can go there. Okay, we'll meet you at Chick-fil-A.
so we're gonna get something on quick.
Bye.
Yeah.
Okay, that's where I was gonna go.
Just let me know the time and we'll get there, brother. Bye. It was,
What I told you, we can't go there.
Huh?
That's where we're going, we can't.
we always meet together everywhere we go.
I know.
Alright, so for VD, we're gonna use C0 over, or dose over C0. So VD equals, gotta solve for the dose.
Hi, Tommy. Hi, Tommy.
I have Abdullah.
I have gone get like ordered 2 photos of a big like. Yeah, but like.
This is going to judge you.
Yeah, but
That was pretty funny.
absolutely fine. Please don't find it today.
Alright, so what do you guys get for VD?
3,600.
Yes, but that's good. What are the units?
Yeah, that's very good.
Perfect, really, that's it. If he doesn't give you like, if find the video or drug in ML, you have to find in leaders. But if he tells you milliliters, then find. Yep.
Alright. Now it's asking us to find the half-life of the drug, so we have the K. So all we gotta do is plug and chug into the formula. 0.693 over 0.4 T half-life equals, what do you guys get for half-life?
Yes, that's good.
Yeah. That is.
Should be 1 decimal place. 1 decimal place. So it's not K or it's not T. I mean, it's not C basically. 1.7.
Yep. Alright, and the last one is asking for the area under the curve. Dose over clearance, which is just BD over.
Yes, dose over dose divided by VD times K. This is.
You guys get from the AUC?
Alright,
22.
Is the same.
what did you get?
I go 225.
Yeah, I got 225. So you off by,
A lot.
no, the decimal place basically.
225.7, but this is milligrams per liter, 10 hours. If you use the milliliter one,
Did you use 3600 for VD?
No, I missed 32.5.
I'm fine.
For those? So you know, you got it.
Yeah.
It's right, that percent you're off by 1 decimal, so it's not a lot.
In class, use a different way.
Really?
AUC equals CO over K. Which I don't know why, because it's not even open.
a CO, because I think dose over PD equals CO.
Like you should just.
Yeah, it doesn't matter. It's all the same stuff.
Yeah.
225.7.
Well, I got 0.1. It's at least, it's a decimal place. I mean, it's rounding problem. I don't think that matters that much. As long as you didn't get like 222 and I got 225, it's been between like that 225.
Oh.
Can't be, that's low. Okay. Anyone know the shots?
Stuff. All right, two more questions, guys. Question number 7, if a drug is administered by continuous IV infusion at a rate of 40 milligrams per hour and produces a steady state plasma concentration of 25 milligrams per liter, how would you adjust the infusion rate to achieve a new steady state of 45 milligrams per liter?
So if you look at equation sheet, how do you think K0 and CSS are related? Inverse or direct? Direct? Yes.
So in order to do this, you would do CSS one
How would we know, like, the regular interest, cause I just remember him
Yeah,
saying.
No, it's from the
So,
equation. If you look at the.
yeah, so if you go here to the equation sheet, so you see CSS right here. So since CSS and
So basically.
K are above the line, that means that they're directly proportional or directly related. And since K and VD or VD's on the bottom here, that means that they're inversely.
Like mathematically, if the K0 goes up, the CSS will go up.
Right.
And if the VD goes down up, but since it's a denominator, then CSS will go down.
Yep.
Make sense?
Makes sense, yeah.
All right.
That's what they are inversely and they're direct, K0 and CSS. So we do the cross multiplication.
So CSS one is 40. 25.
And this is from our calculations class, remember? I don't. What did you guys got? Bless you.
You guys get,
I'll do the half to bless. I'll do the half for half to bless.
72.
beautiful, yep, 72.
I love the way you said beautiful. Can you say it again?
Beautiful. I tell you all the time.
You call me beautiful every day. How was your weekend, Tom?
It was very very eventful.
How much did you?
What?
How much did you earn?
Like 200%.
200%. Wow, boy.
All right, last question. For a drug with a clearance of 50 milliliters per minute and a VD of 0.7 liters per kilogram in a patient weighing 70 kilograms, how much time will it take to reach 75% steady state after continuous IV infusion?
Pay attention on the units
Yep,
in the question.
What's the answer to last?
72.
72 milligrams per hour. All right, so which equation are we going to use for number 8? Gotta go to our equation sheet.
Yeah, maybe I'll find K first. If I get mine.
All right, so the first thing we have to do is we have to solve for our, so the end equation that we're gonna end up using is gonna be ln 1 minus percent equals negative k t. So we need to solve for k in order to use this equation.
How do you think we'll use, so for K, they gave us clearance and they gave us reading. What equation will we use? Find K. Sorry? Yeah. So
49 per E. Good, so we're gonna use clearance equals VD times K. So clearance is 50 milliliters per minute, so we wanna change that to, yeah, we wanna change that to hours. So 50 mLs over minute times, 60 minutes over 1 hour. So equals
That's what you do.
3,000 milliliters per hour. So we are going to get, yeah, and then we also need to put this into liters, so it's gonna be 3 liters per hour.
Does that make sense? But you see VDs in meters, we need to change it to meters.
Yep.
And everything, rate is per hour, so we have to change it in hours. Find the K per hour. 0.061.
All right, so now that we have, K, we can go back over here, so ln 1 minus 0.75 equals negative K, which is going to be 0.061 T.
I told you. They hit a.
Here we go, negative 1.39 equals negative 0.061 T.
So like one of them was even clearance. Clearance.
Yes, 22. 22%, yeah. So what'd you guys get for a final time?
What do you guys get for final? 1 second is over. You just look at the board.
I wanna do it myself.
I saw you looking at the board though. Are we guys good? Are we good?
Yeah.
All
You're
right,
feeling better for the math part at least?
Yeah.
good,
No, it absolutely.
I hope it helped.
Like.
all righty. Alex, come here.
What?
How do we
Is it
stop
recording?
recording?
Is it recording?
You hit the stop recording button.